In this session, we're going to talk about solving quadratic equations. And remember, there are three methods of solving. I suppose there are four, but we're going to talk about three methods of solving quadratic equations. The most common method, I'll get it in a minute, solving quadratic equations. Sorry for the mix-up there. The most common method, what we normally try, is the method of factoring. Now, in some special cases, some special types of quadratic equations, we use the square root method. Now, this method we can't use all of the time, but this is special circumstances. I'll just write that out there. And you'll see what I mean when we go about solving this type. And then the third method is by using the quadratic formula. Now, the quadratic formula will work for all quadratic equations. It solves every single quadratic equation. The factoring method doesn't always work because sometimes we can't factor the polynomial involved needed to solve that equation. And of course, as I said, the square root method is we only use it under special circumstances. But we can always use the quadratic formula. Well, what do we mean by a quadratic equation? Well, let's look at the first example here. And again, I expect this to be review, so I'm not spending a great deal of time on each type of problem. Solve x squared minus 4x plus 3 equals 0. Now, it's a quadratic equation if we can write the equation in this form. And the quadratic equation portion means that the highest power of the unknown is 2. And of course, it has to be a polynomial that we're dealing with, so we don't have variables and denominators, we don't have variables and under square roots, and so on. So here's a typical looking quadratic equation. Now, the factoring method, and that's what we're going to use first, because that's the most common, if you recall, means that we need to have all terms on either the left side or the right side of the equation and 0 on the other side. So we have that set up here. And then we take the side where all of the expression is, okay, all the terms, and we go about trying to solve that, factor that side. And in this case, I think you'll recognize that we need to say x times x. And because the sign we have here is positive, the two signs are the same, either both positive or both negative. And because that's negative, we recognize both of these are negative. And if we look at a combination of 1 times 3, of course, that will give us a positive 3, and in the middle it gives us a negative 3x and a negative x together, which is negative 4x. So this is the correct factorization. Then the idea is we have a product of two expressions is equal to 0, and the only way that can happen, is for one or the other or both expressions themselves to be 0. So we set each of the factors, x minus 1 and x minus 3, we set each of those to 0 and solve accordingly. And of course, in this case, we add 1 to both sides and we get x equal 1. In this case, we add 3 to both sides and we get x equal 3. So we have two solutions to this quadratic equation. And that's normal. Remember that. Most quadratic equations have two solutions. And I'm going to remind you of that a little later on. And you're going to see it over and over. Occasionally there's only one solution, but usually two. Okay, well, let's take a little bit different twist on this solving a quadratic equation using the factoring method. Here we're asked to solve the equation x squared minus 4x plus 3 is equal to 8. And we're going to use the factoring method, but we'll see that in a moment. The first thing to recognize here is that we don't solve a quadratic equation normally until we have 0 on one side. It just doesn't lend itself to the technique that we saw above. And so we have to deal with the 8 that's on the right side of this equation, and we do that, of course, by subtracting 8 on both sides. So we have the x squared minus 3x minus 4x plus 3, and since we're subtracting 8 on both sides, we have to subtract it on the left, and of course when we subtract it on the right, we get 0. Now, of course, the left side will now simplify to x squared minus 4x minus 5 equals 0. Now, this is the form that we need. We call this the standard form, but we have to have all terms on one side and 0 on the other before we proceed. We're ready to proceed, and that procedure, of course, is to factor the side that has all the terms. Now, remember, we still have an equation. All we're doing, so that equals 0 is still there. All we're doing is factoring the left side and replacing x squared minus 4x minus 5 by its factored form. So once again, we have an x times an x. This time that sign's negative, so one of these is positive and one of these is negative. And I think in this case we'll recognize that if we put a plus 1 there and a minus 5 there, then we get the correct factored form. And I'll let you double check that. I don't think I need to remind you at every step everything we do. So next we take the x plus 1 factor, set it to 0, and then we'd also take the x minus 5 factor and set it to 0 when we solve each of those equations. Well, on the left equation, we subtract 1 on both sides, and of course 0 subtract 1 is negative 1. And on the right side, we add 5 to both sides, and 0 plus 5, of course, is just 5. And so, again, we see that we have two solutions, and we can take the time to check these solutions and make sure they do, in fact, solve the equation. But if we've done our work correctly, then we won't have trouble there. They, in fact, are solutions. Okay, let's go to the next page and increase the difficulty a little bit. Okay, as you can see, our next problem, equation to solve, is 3x squared is equal to 6x plus 24. Once again, we're in a position. Let me write the equation over here as we're going to solve, because I may want to use some of the space. So here's the equation we're to solve. And you see that we're faced with the situation that we don't have it in the right form. We don't have 0 on one side. And so we need to make a decision on whether we want 0 to be on the left or right. And unless there's some special circumstances, I usually have 0 on the right, which means I need to get rid of the 6x and get rid of the 24 that exists on the right now, and I'll do that by subtracting 6x and subtracting 24 on both sides. So, of course, when I subtract 6x on both sides, when I subtract it on the left, it becomes minus 6x, and when I subtract 24 on the left, it becomes minus 24. And of course, when I subtract both of those on the right side, I end up with 0. That's the reason I did it. Now, typically, unfortunately, we teach the next step we many times teach, and so let me come over here and point this out. The next step we normally teach is that we look at that left side and we think about factoring it, but in this case we notice that there's a 3 that is a common factor with the 3x squared and the 6x and the 24. And so a lot of times what we're taught in previous algebra classes, in our algebra classes, is before we try to factor the trinomial, factor out any common factors. Okay, so that would be, it would look like this if I factored out a 3. Now, then we go about factoring the x squared minus 2x minus 8. But what I want to appeal to you here, that if we see a common factor in an equation of this type, rather than worry about factoring that common factor out, why don't we just divide it out? See, what we could have over here is we could take this side and divide by 3, and that would eliminate that factor of 3. And then, of course, we'd have to divide the other side by 3. So we'd get rid of these two 3's. We'd have x squared minus 2x minus 8. And, of course, 0 divided by 3 is just 0. And so it gives us a much simpler equation to solve. But rather than do it in the way that I've shown over here in this boxed off area, when I notice that I have a common factor on the left side, I'm going to imagine, and see, I'm going to kind of box that in too. I'm going to imagine that I'm dividing both sides by 3. Well, when I divide the left side by 3, it means I really have to divide every term by 3. And so I'm imagining that this is what's going on. Of course, I have to divide the other side by 3, so it looks like that. But of course, I can really do this in my head, because the 3x squared divided by 3, of course, the 3's cancel, and so I just have x squared. And then a minus sign. And the 6x over 3, well, the 6 over 3 is 2, so that becomes a 2x. And then I have that minus sign. And the 24 over 3 is just 8. And 0 over 3, of course, is 0. And so what I will normally do when I'm dealing with an equation like this is I would have skipped that boxed area here and over on the right as well, and rewritten the equation in a way that's much easier for me to solve. Okay, now we continue. So we factor the left-hand side if we can, and that can be a problem. Not everything we can factor very easily, but I think we can here, and x times an x, and we see because we have the minus sign in front of the 8, that means the two signs in the binomial have to be different, because we've got to have a positive times a negative or a negative times a positive to get negative 8. And then we just imagine and experiment a little bit, and in this case we find out that we have to put a 2 in this position and a 4 in this position. If we miss those positions, we'll get, of course, the wrong factored form. It won't be factored correctly, and on top of that, even worse, we won't get the correct answer. But now we, of course, set each of these factors to 0, which we're used to doing already, and then we solve each of the simple equations. And here we'll get x equal negative 2, and of course here we'll get x is equal to positive 4. And so once again, we have our two solutions, and that's what we normally expect. Now, all of these examples have been using the factoring method. Now, in some cases, there's a quicker way than factoring, but it's those special circumstances, and that's the idea of the square root method. And in fact, the square root method will work when we can't even factor so easily, but we still have to have special circumstances. And those special circumstances are that we don't have in the equation the variable to the first power does not exist. That is, so here would be an example. X squared, so we'll say example 4 here. Solve x squared minus 36 is equal to 0. Well, the first thing that, well, let's come down here. If we were to use this factoring method, then what we could say is, oh, look at that left-handed side. That left side is something that I can factor. X squared minus 36 equals 0. That left side is the difference of two squares. Okay, so on the left side, that would be x plus 6 times x minus 6. That's how we get x squared minus 36. And so we can set each of these factors to 0 once again. Okay, now I said we're talking about the square root method, but I'm not using that yet. Okay, and in here we'd get x equal negative 6, and here we'd get x is equal to positive 6. Once again, two solutions. But the square root method approaches this differently. And the big issue here, as I said, this quadratic equation has the term involving x squared, and it has the term involving a constant, but it doesn't have the term involving just x. And under those circumstances, we do this differently. We solve for x squared before we solve. In other words, we don't want a 0 on one side. We want x squared on one side and the constant on the other. So in this case, we're going to add 36 to both sides, and we end up with x squared is equal to 36. And the reason this is called the square root method is we know that when we have something that's squared gives us a number, there's two ways to get that. We can either square a positive result or we can square a negative result. And so we say, okay, well, x is either plus or minus, and the number that we have to square is the square root of the number that's on the right side. And so in this case, we end up with saying, oh, x is plus or minus the square root of 36, which is 6. And so that indicates both the positive 6 solution and the negative 6 solution. And of course, that was easier than going through this process of factoring. So this is a special technique, and many times I will employ this technique as opposed to factoring when these special circumstances apply. Okay, well, once again, let's pause and go to the next page and look at more examples of this type. Okay, you can see here we're supposed to solve x squared minus 7 equals 0. And you can also see that this is similar to what we just did, that it involves x squared and it involves a constant, but not x to the first power. And we would have trouble on this problem factoring because x squared minus 7 is not the type of thing that we're normally used to factoring, because it's not what we think of normally as the difference of two squares. So we'll apply the method that we just learned, and that was that we get x squared by itself by adding 7 to both sides. And when we do that, then we're back to the situation where we have x squared is equal to a single number. And so that means the value, the thing we're squaring, x, can either be positive or negative. And what we have to square to get 7 is the square root of 7. And so we end up with, again, two solutions. One is positive square root of 7, and the other one is negative square root of 7. And this technique was very easy here, where factoring would have been very difficult for us to do. Now, in the next example, it will be, of course, using the same technique, but it's a little bit more involved than what we've been doing so far. We're asked to solve 2x squared minus 10 is equal to 0. Now, it's a little more involved than what we've been doing, but it still is a quadratic equation that has the x squared term and the constant term, but no x to the first power term. And so whenever that happens, we try to get x squared alone on one side and constant alone on the other side. So in this case, we see that what we would end up doing is adding 10 to both sides. So we would have 2x squared is equal to positive 10 on the right-hand side. Now, of course, what the issue is in this case is we have 2x squared instead of x squared. And it's imperative that we get x squared alone. So we're going to divide on both sides by 2 so that we get x squared alone. Of course, when we divide on the left side by 2, we end up with just x squared. And I've shown dividing on the right side by 2, but of course 10 divided by 2 is 5. So I'm going to save a little space here. And now, as we've done before, if x squared is equal to a number, then x can either be positive or negative. And what we have to square to get 5 is the square root of 5. So we end up again with two solutions, either positive square root of 5 or negative square root of 5. Both of those values of x will solve this equation. Okay, let's solve this problem. solve this equation. Solve 2x squared minus 3x is equal to 0. Okay. Now, quite frankly, I'm trying to mislead you. I started to say trick you, but I'm not really ever trying to trick anybody. What I'm trying to do is to let you recognize if you're not careful, your mind makes the wrong decisions. So we can't use this technique on this problem, the technique we've been using, the square root method, because this quadratic equation has the x squared term, but it also has x to the first power term. It doesn't have a constant term. So the square root method does not apply here, as we've done in the several previous problems. But this is so simple, many students overlook it. We can use the factoring method very easily here. And just because the left side is not a trinomial, as we did at the very beginning, the left side is very factorable, because we see that we have an x factor in each of the terms. So x itself is a common factor. We can factor x out. I think that's all we can factor out. X times 2x gives 2x squared, and x times negative 3, of course, gets negative 3x. So we, in fact, do have that left side factored now, don't we? So once we have the left side factored, regardless of what the factors are, as long as they involve a variable, we set each of the factors equal to 0. So one of the factors is that x in front. We set it equal to 0. And then we set the other factor, which is 2x minus 3, equal to 0. And then we solve each of those equations. Well, x equals 0, there's nothing to solve. That is, x equals 0 is one of the solutions. In the 2x minus 3 equals 0, we have a little more work to do. We need to get x alone, and so we do that by adding 3 to both sides. That leaves just 2x on the left side, and 0 plus 3 is just 3. And then we divide out that 2 in front of the x, don't we? See, we have to take that and divide by 2 because we want to get the x alone. So we divide on the left side by 2, we've got to divide on the right side by 2. Of course, on the left side, the 2's cancel, so we have x alone, and on the right side, we have 3 over 2, or 3 halves. So you see, again, we have two solutions. Don't forget that first solution of 0, along with the second solution of 3 halves. And this was really very simple, but we might have overlooked using the technique of factoring by factoring out a common factor. Be careful of that. That was the purpose of this. Well, on the next page, I want to investigate the idea of solving quadratic equations where factoring is really not an option, because we don't really have a way for us to factor the next types. So let's go to the next page and begin that. Okay, here, as I mentioned, we're going to solve quadratic equations using the quadratic formula. And as I mentioned earlier, we can always solve a quadratic equation using the quadratic formula. It's just tedious, and so if there's a quicker way, we like to use it, the quicker way. But as again, this will always work. Now, here's a situation, for instance. Let's see, this is example 8. Okay, and we're to solve x squared minus 2x minus 1 equals 0. And the first thing that I would challenge you with is this looks like what we similar to what we started with. But x squared minus 2x minus 1 is not something that we can factor by using whole numbers. So there's no way this is factorable by using whole numbers, integers. To factor it, we have to use very special techniques, and we have to introduce strange numbers to be able to factor it, like either complex numbers or irrational numbers. So the factoring technique won't work. And I'm just going to make a note of that. Factoring in this case won't work since we can't factor. So we have to use the quadratic formula. So let me remind you of what that is. I expect that you know how to do that. You've seen this before, or you shouldn't be in this class. We're assuming that we have a quadratic equation written in the standard form, meaning all of the terms are on one side and 0 on the other. I've shown all the terms on the left side and 0 on the right. Now the A, the B, and the C represent constant numbers. And the A represents the coefficient of the x squared term, which can be 1 or -1 or 2 or 1/2. It can be lots of things. B is the coefficient of the x to the first power, and it could even be 0. B could be 0. We assume that A is not 0, otherwise we wouldn't have a quadratic equation. But B or C, either one can be 0. They can be positive numbers, they can be fractions, they can be negative numbers. They just represent coefficients, either a coefficient of x or the constant term. Now the quadratic formula says here's the way we can come up with the solutions to an equation of that form. And if you remember, is a complicated fraction. In the top of the fraction, the numerator is the opposite of whatever the b value is, and then plus or minus and a square root. Okay? And under the square root, we have the b value squared minus 4 times the a value times the c value. We just say b squared minus 4ac. And the denominator of this fraction is 2a, or 2 times the a value. Now, the plus or minus, that's double symbol there, is really explaining that normally we'll expect 2 solutions. To get one of the solutions, we use the plus sign, and to get the other solution, we use the subtraction sign. And the only time we wouldn't get 2 solutions is if that square root ended up being a 0, because plus 0 and minus 0 gives the same result, so we would only have 1 solution. Okay, now in this problem, we need to apply this formula. So the first thing we have to do is identify the a, b, and c. And remember, a is the coefficient of x squared. First, we have to have all terms on one side in the correct order, as we do. And then we have to identify the a, b, and c. And the a is the coefficient of x squared, which is 1. And the b is the coefficient of x, which is -2. And the c is the constant term, and that's -1. So what we do next, of course, let me kind of move down here where I have more room. We simply substitute those values into the formula. So we say the opposite of b, and I like to put little parentheses where I'm going to put my b value. So that's the opposite of -2 plus or minus, I have a feeling I didn't make that long enough, a square root. And we have under the radical the b squared. So it's important to put the little parentheses for b, and the b value is -2. So I write that correctly that way. And then minus 4 times our a value, which is 1, and times our c value, which is -1. And then we divide all that by 2 times a, and our a value is 1. And of course, the next thing we do is we go back and we start simplifying that little at a time. The opposite of -2 that we have at the very beginning is just +2, isn't it? And then we have plus or minus, a square root. Now, when we square -2, we get +4. And then we look at this part of what we have, and we think -4 times +1 times -1. Well, when we're multiplying and we have 2 negatives, it ends up being positive, doesn't it? So we're going to have a plus there, and of course, then we've decided the sign. See, we have a negative times a positive times a negative will end up being positive. And that's the reason I wrote that positive sign. Then we just have to worry about the numbers. Well, now we have a 4 times a 1 times a 1. Well, of course, 4 times 1 is 4, times the next one is still 4. So we end up with a 4 in that position. And then on the bottom, 2 times 1, of course, is just 2. So we go back, and now we can add what's under the radical. We have 2 plus or minus the square root of, and 4 plus 4 is 8, and all that's divided by 2. But we're not done. The square root of 8 can be simplified. Now, we can't resolve it. That is, we can't say the square root of 8 is 3, or the square root of 8 is 2, because it's not. But we can simplify it. And we use properties of radicals that we should be familiar with. And that is, we can think of 8 as 4 times 2. And the reason I want to do that is the 4 portion I can take the square root of, can't I? So this is the square root of 4 times the square root of 2. And I know the square root of 4. Oh, I'm running out of ink. Let me pause here. Okay, I'm back. Probably didn't even notice I left. I have new ink in my pen. So we have square root of 4 times square root of 2, but square root of 4 is 2. We can't resolve square root of 2. So square root of 8 becomes 2 square root of 2. Okay, so now we can go back to this equation, this formula, and we can replace square root of 8 with 2 times the square root of 2. And all that's divided by 2. But we can still simplify. Here we have a fraction. And we'd like to simplify that fraction. Now, let me remind you, okay, and I've probably reminded you this before, but let me remind you, let me do this before we finish out this problem, because you need to understand that, for instance, if we had 5 plus 10 and we divided that by 5, everybody knows that 5 plus 10 is 15, and 15 divided by 5 is 3. So we know what this fraction really is. But too many times, as a student, we get careless. And we say, oh, there's a 5 on top, there's a 5 on bottom, and so we cancel that. And of course, that would just leave a 10, wouldn't it? And that's clearly not right. So what did we do wrong? Well, we canceled things that we're not allowed to cancel. The only thing we can cancel is factors of the numerator and factors of the denominator. We can't cancel things that are part of terms. So this technique doesn't work at all. Now, we could have, and there would be no reason to do this, but we could have said, look, in the numerator, 5 goes into 5 and to 10. So we could have factored this by saying 5 times 1 plus 2. See, 5 times 1 is 5, 5 times 2 is 10. Now, the 5 on top is a factor of the numerator, and 5 on bottom, since it's alone, is a factor of the denominator. And certainly that just leaves 1 plus 2, which is 3. So the idea is we have to factor first, and that's really the thing that we want to do. Factor before you cancel. So I know many students would have been maybe incorrect by jumping the gun. In fact, they're canceling that first 2 on top and that 2 on bottom, but we can't do that. So what we have to do is we have to look at that numerator and recognize 2 goes into this and 2 goes into this. So 2 is a common factor. And when we factor 2 out, that leaves us a 1 in the first position, that plus or minus sign, and a square root of 2 in the second position. And in the denominator, we have a 2, and those 2's can now be canceled because 2 is a factor of the numerator. So we end up with x is equal to 1 plus or minus the square root of 2, which, as a reminder, let me tell you, that means 1 plus the square root of 2 is a solution, and also 1 minus the square root of 2 is a solution. That plus or minus is really telling us that we have 2 solutions. Now, there is another way to have done what we did up here. So let me show you an alternate, rather than factoring there, an alternate way to simplify. we should have remembered from previous work that if we are dividing something by a number, that means we're dividing everything on top. We kind of saw this when we were solving a little earlier. That 2 on bottom says we're dividing into both terms. And so we can actually take that 2 plus or minus 2 root 2 over 2 and write it as 2 fractions. The first 2 divided by 2 plus or minus the 2 root 2 divided by 2. We're just dividing it into both. And of course, if we add fractions together with the same denominator, we would get what we had above. And of course, in that first position, 2 over 2 is 1. And in the second position, the 2 over 2 again is 1, or would cancel, leaving square root of 2. So that's another way we could have done that rather than factoring out that 2. Let's see if I have one more that I'd like to do here. I think that's good enough for now. I hope that gives you an idea that occasionally we have to fall back to a more difficult method of of solving a quadratic equation by using the quadratic formula. No other method would have worked here. Okay, well, that's the end of solving quadratic equations for now.